One skill, 80% of job postings. If you only learn one thing in 2026, learn RAG. Right now, there is an invisible wall being built in the tech industry. On one side, you have traditional developers worried about layoffs and stagnation. On the other, you have AI engineers commanding salaries of $200, even $300,000. The difference isn't that the AI engineers are math geniuses. It is that they understand one specific architecture that every single company is desperate to build. Retrieval Augmented Generation, or RAG. Companies do not want generic chatbots. They do not want an AI that hallucinates or makes things up about their products. They need systems that understand their private data, their legal documents, and their customer history. That is exactly what RAG solves. It is the bridge between a generic AI model and actual business value. And here is the best part, the secret that most technical tutorials complicate. RAG sounds intimidating. It sounds like advanced rocket science for data, but it is actually simpler than most backend applications you have already built. If you can understand how a librarian finds a book on a shelf, you can understand RAG. In this video, I am going to strip away the hype. We are not going to look at confusing Python scripts or terminal windows yet. Instead, I will give you a complete visual breakdown of how RAG works, the three distinct components you need to master, and exactly how to talk about it in a system design interview to land a high-paying role. By the end of this video, you won't just understand the acronym, you will have the conceptual clarity to put it on your resume. Stop worrying about AI replacing you. Let us look at the architecture that makes you irreplaceable. To understand why RAG is the golden ticket for your career, we first have to look at the massive, expensive problem plaguing the tech industry right now. It is a problem of trust, and it is the primary reason why thousands of AI pilots are failing to reach production. Imagine a typical scenario in a modern enterprise. A company, let us call them Tech Corp, decides they want to integrate AI. The CTO is excited. The board is demanding it. So the engineering team connects a standard large language model like GPT-4 to their internal Slack channels or their customer support documentation. They ask the AI a simple question: what is our refund policy for enterprise clients? The AI answers confidently, "It sounds perfect. The grammar is flawless." But the answer is completely wrong. It just hallucinated a policy that does not exist, potentially exposing the company to a massive lawsuit. This is the hallucination barrier. It is the wall that separates cool weekend demos from actual enterprise software. And right now, most software engineers do not know how to break through that wall. This creates a brutal divide in the job market. On one side, you have excellent full-stack developers, back-end engineers, and data analysts. They are talented, they know how to build APIs, they know how to manage databases, and they know how to center a div. But when they try to enter the AI space, they hit a ceiling. They try to solve the hallucination problem by prompt engineering, endlessly tweaking the text they send to the model, hoping for a better result. Or worse, they think the solution is fine-tuning, creating a custom model which is incredibly expensive, slow, and often unnecessary. They are trying to solve a data retrieval problem with a model creation solution. The result is that their resumes get passed over. We are seeing a specific trend in 2026, hiring data. Recruiters are no longer impressed by generic AI enthusiasm. They are looking for AI architecture experience. They want to know if you can build a system that grounds the AI in truth. If you are serious about becoming that architect, make sure you subscribe to the channel right now. We are breaking down every layer of the AI stack this year, and you do not want to be left behind with the legacy developers. Hit that button and let us keep going. Consider the frustration of the current developer experience. You might be feeling this right now. You watch a tutorial on YouTube. The instructor opens a code editor, imports a library like langchain, writes 10 lines of Python, and boom, a chatbot that talks to a PDF. You copy the code, it works, but then you try to apply it to your company's database of 10,000 PDFs and everything breaks. The context window overflows, the costs skyrocket, the answers degrade. You do not know why because you only learned the syntax, not the architecture. This is the danger zone. You are entering a You are stuck in tutorial hell, knowing enough to run a script but not enough to design a system. Meanwhile, the demand for engineers who can design these systems is outpacing supply by a factor of 10 to 1. The consequence of staying in this danger zone is professional stagnation. As AI models become commodities, meaning GPT-5, Claude, and Gemini all become roughly equal in power, the value of an engineer is not in knowing how to call an API. The value is in knowing how to feed that API the right data at the right time. If you cannot build a pipeline that reliably fetches the correct information before the AI speaks, you are building toys, not tools. And the market has stopped paying premium salaries for toys. But here is the good news. The solution to this problem, the RAG architecture, is not magic. It is not complex mathematics. It is fundamentally a systems engineering problem. It is about organization. If you have ever organized a messy filing cabinet or built a search feature for a website, you already possess the foundational logic needed to master RAG. You just need to translate that logic into the new language of vectors and embeddings. The engineers who bridge this gap are the ones who stop asking, how do I make the AI smarter? And start asking, how do I give the AI better memory? That shift in perspective is what we are going to map out today. We are going to move you from the frustrated developer trying to debug a hallucinating chatbot to the architect who builds the systems that power the enterprise. Let us dismantle the complexity and look at what is actually happening under the hood when we talk about Retrieval Augmented Generation. At its core, Retrieval Augmented Generation is the architectural equivalent of an open book exam. To understand the solution, we have to visualize how a standard large language model works without RAG. Imagine a brilliant, eccentric professor sitting in an empty room. This professor has read the entire internet, but they stopped reading in 2023. If you ask them a general question like what is the capital of France, they answer instantly from memory. But if you ask them, what did our sales team discuss in the meeting last Tuesday? They have no idea. They might even make up a story just to be helpful. This is the limitation of relying on the model's internal training data. RAG changes the rules of the room. It introduces a new character into our visual metaphor, the librarian. When you build a RAG system, you are not teaching the professor new information. You are giving the professor access to a library of your company's private files. Here is the high-level visual of how this solution works. Picture a diagram with 3 distinct stages moving from left to right. Stage 1 is retrieval. This is the librarian's job. When a user asks a question, the system does not send that question straight to the AI. Instead, it pauses. It takes the user's query and acts like a search engine. It scans your company's database, your PDFs, your emails, your Slack history, and finds the specific paragraphs that contain the relevant information. It retrieves the truth. Stage 2 is augmentation. This is where the magic happens. The system takes those retrieved paragraphs and staples them to the original user question. It creates a new, enriched prompt that looks something like this. Here is the background data I found in the files. Using only this data, please answer the user's question. This is the augmented part of the acronym. You are augmenting the prompt with context. Stage 3 is generation. Finally, this enriched packet is handed to the professor, the large language model. Now, the AI does not have to guess. It does not have to hallucinate. It simply reads the data you provided and generates a clear, natural language summary. It transforms from a creative storyteller into a precise analyst. This might sound simple, almost trivial, but the implications for your career are profound. By mastering this pattern, you solve the single biggest bottleneck in enterprise AI. You decouple the reasoning engine from the knowledge base. Think about what that means for a business. If a company updates its refund policy today, they do not need to spend 3 months and $1 million retraining their AI model. They just update the document in the folder. The librarian picks up the new policy instantly on the next search. The system is always up to date, always accurate, and always grounded in your specific data. This is why RAG is the dominant design pattern for 2026. It turns the black box of AI into a transparent, controllable system. For a software engineer, this is the moment where the fog clears. You realize that building AI applications is not about training neural networks or doing complex calculus. It is about data engineering. It is about building a robust pipeline that moves data from storage to the model efficiently. If you have experience building APIs, managing databases, or handling search queries, you are already 80% of the way there. The only missing piece is understanding the specific tools we use to make that retrieval step happen. We need to understand how computers understand meaning, not just keywords. We need to understand the engine that powers the librarian. That engine is built on a concept called vector embeddings. And while the name sounds like something from a physics classroom, the concept is surprisingly intuitive. Let us visualize exactly how the system finds the right book in the library. To understand vector embeddings, we have to stop thinking like humans and start thinking like a computer. When you see the word apple, your brain instantly connects it to a red fruit, a pie, or maybe a technology company. You understand the meaning behind the symbols, but a computer does not see meaning. It sees a string of 5 letters, a PPLE. If you ask a standard database to search for fruit, it will look for the exact letters FRUIT. It will not find apple because the letters do not match. This is the limitation of keyword search, and it is why old-school chatbots were so frustrating. Vector embeddings solve this by turning words into numbers, but not just any numbers, coordinates. Imagine a massive, multi-dimensional map. On this map, words that mean similar things are located close to each other. The word dog is parked right next to the word puppy. The word cat is just down the street, but the word car is in a completely different city, far away. When we create an embedding, we are essentially taking a piece of text, like a sentence from your company's PDF, and calculating its exact GPS coordinates on this map of meaning. We call this a vector. Now visualize what happens when a user asks a question. Let us say they ask, "How do I reset my password?" The system takes that question and calculates its coordinates. It drops a pin on the map. Then it simply looks around that pin and asks, what other documents are located nearby? It might find a document titled Login Troubleshooting. The words are different, reset versus troubleshooting, but the meaning puts them in the same neighborhood on the map. This is the breakthrough. This is semantic search. It allows the system to understand intent, not just syntax. And for an AI engineer, understanding this concept is the difference between building a fragile search bar and building an intelligent system. But having these coordinates is only half the battle. You need a place to store them. You cannot just stuff these complex vectors into a standard Excel spreadsheet or a traditional SQL database. They are not built for it. This brings us to the second pillar of the RAG architecture, the vector database. You will hear names like Pinecone, Weaviate, Chroma, or Milvus thrown around in job descriptions. Do not let these names intimidate you. They are just specialized filing cabinets. Think of a traditional database like a library organized alphabetically. To find a book, you need to know the exact title or author. A vector database, on the other hand, is organized by context. It is like a library organized by vibes or topics. If you walk in and say, "I want a sad story about a robot," the vector database does not check titles. It checks the emotional and conceptual location of every book and hands you the ones that match that specific feeling. In a production environment, this is critical for speed. When you are building for enterprise clients, you might have millions of documents. Searching through them one by one would take hours. Vector databases use advanced math to find the nearest neighbors in milliseconds. This speed is what makes the chat experience feel instant. If you are finding this breakdown helpful, do me a favor. Hit the like button so YouTube knows this is high signal content. It helps us keep these tutorials free for everyone. Now, let us look at the third critical component that often trips up beginners. The ingestion pipeline. This is the preparation phase that happens before a user ever types a question. This is where you, as the engineer, have the most impact on quality. You cannot just dump a 500-page HR manual into the database as one giant block. If you do, the location on the map becomes too broad. It is like saying the United States is your location rather than a specific street address. The AI will not know which specific part of the manual answers the question. To fix this, we use a technique called chunking. Visualize a long document being fed into a shredder, but a smart shredder. It cuts the document into small, manageable paragraphs or chunks. Each chunk should contain one distinct idea. We then turn each specific chunk into its own vector and place it on our map. So instead of one pin for the whole book, we have 500 pins representing every specific policy, rule, and definition inside that book. When the user asks about holiday leave, the system does not retrieve the whole HR manual. It retrieves just the specific paragraph about holidays. This keeps the data precise and it keeps your costs down because you are feeding less text to the expensive AI model. This brings us to the system design view, the exact diagram you need to be able to draw on a whiteboard during an interview. If an interviewer asks you to design a RAG system, do not start writing code. Start drawing boxes. You need to visualize two distinct flows. On the left side of your whiteboard, draw the ingestion flow. This is something that runs in the background. First, you have your documents. Second, they go through the chunker. Third, the embedding model turns those chunks into numbers. And fourth, the vector database stores those numbers. On the right side, draw the retrieval flow. This is what happens when a user clicks send. First, the user question comes in. Second, the same embedding model turns that question into numbers. Third, the vector database search finds the matching chunks. And fourth, the LLM takes the chunks plus the question to generate an answer. This separation is key. Most junior engineers think it is all one big script. Senior engineers know these are two separate systems that interact. The ingestion flow happens offline, maybe once a night to update the docs. The retrieval flow happens in real time. Understanding this distinction is what justifies a senior salary. It shows you are not just copy-pasting a tutorial. You are thinking about latency, cost, and data freshness. But there is one final piece to this puzzle that separates the OK architectures from the exceptional ones. It is the concept of the context window. Every AI model has a limit on how much information it can hold at once. Think of it like a short-term memory limit. You cannot ask an AI to read 10,000 books and answer a question in 1 second. It will forget the beginning by the time it reaches the end. RAG is the workaround for this memory limit. By retrieving only the top 3 or 5 most relevant chunks, you are curating the information. You are telling the AI, ignore the noise, focus only on these 3 paragraphs. This dramatically reduces hallucinations because the AI is no longer guessing. It is analyzing. It is comparable to the difference between asking a student to write an essay from memory versus asking them to write an essay with the textbook open to the exact right page. So, why does this matter for your career right now? Because every major company in finance, healthcare, and law is sitting on mountains of private data. They cannot send this data to ChatGPT public training. They need private instances. They need controlled answers. They need RAG. They need engineers who understand that better AI does not usually mean a smarter model. It means better data retrieval. If you can optimize the chunking strategy or choose the right embedding model, you can make a cheap, fast model outperform a massive, expensive one. That is the kind of efficiency that CTOs love. You now understand the theory. You have the mental model of the librarian, the map of meaning, and the smart filing cabinet. But theory alone will not get you the job. You need to know how to actually build this. You need to know where to start. In this next section, I am going to give you a specific step-by-step roadmap to build your first RAG project this weekend. One that is impressive enough to put on your GitHub and talk about in your next interview. So, how do you actually build this without getting overwhelmed? The biggest obstacle facing developers right now is not the difficulty of the code. It is the paralysis of choice. If you search for RAG tools today, you will be bombarded with hundreds of logos. Langchain, llamaindex, Pinecone, Weaviate, Milvus, Quadrant, Haystack. It is enough to make you close the tab and go back to traditional web development. To break into this field, you need to ignore 90% of that noise. You need a default stack, A simple, reliable set of tools that lets you focus on the architecture, not the configuration. Here is the mindset shift. Treat your first RAG project like a hello world, not a production enterprise system. Your goal is to see the data flow, not to scale to a million users. For your immediate next step, I recommend starting with the standard triad. First, you need an orchestrator. This is the glue that connects everything. For this, Python is the non-negotiable language of choice, and a framework like llamaindex or langchain acts as your scaffolding. Think of these frameworks as the construction crew that handles the heavy lifting of moving data around. Second, you need a vector store, the filing cabinet we talked about earlier. For a beginner, do not try to set up a complex server. Use a hosted cloud option with a free tier like Pinecone or Chroma. These allow you to spin up a database in seconds without managing infrastructure. Third, you need the brain. Start with a standard API like OpenAI's GPT-4o. Yes, open source local models are great and free, but they add complexity. When you are learning the architecture, you want to minimize variables. Pay the $5 for API credits so you can trust that the model works, allowing you to debug your code instead of the model's intelligence. Now, let us talk about the project itself. This is where most freshers fail. They follow a generic chat with your PDF tutorial, put it on GitHub, and wonder why recruiters do not call. Recruiters have seen 1,000 chat with PDF apps. To stand out, you need to build something that solves a specific personal problem. Build a chat with my journal app that helps you find patterns in your thoughts over the last year. Or build a resume optimizer where the RAG system retrieves your past project descriptions to help you write cover letters. Or, if you are a developer, build a documentation assistant for a specific library you use often. The difference here is subtle but powerful. It shows you understand data curation. You are not just dumping a random file into the system. You are thinking about the utility of the retrieved information. However, as you build this, you are going to hit the wall that separates junior engineers from seniors. You will build the app, ask it a question, and it will give you a bad answer. A junior engineer looks at a bad answer and says, "The AI is broken." A senior engineer looks at a bad answer and asks, "Was the retrieval bad or was the generation bad?" This brings us to the most critical practical tip for your interview prep. Learn how to debug the pipeline. Common mistake number 1 is bad chunking. If you chop your documents into tiny sentences, the AI loses context. It gets a fragment of a sentence like "it depends on the user," but it does not know what depends on the user. If you chop them into massive pages, the specific answer gets lost in the noise. Experimenting with this chunk size, finding the Goldilocks zone is the actual work of an AI engineer. Common mistake number 2 is the lost in the middle phenomenon. Research shows that LLMs are great at reading the beginning and end of a text, but they often forget information buried in the middle. A smart engineer knows to re-rank the retrieved results, so the most important data is always at the top or bottom, never hidden in the center. When you are in an interview, do not just say, "I built a RAG app." Say, "I built a RAG app and I noticed that smaller chunk sizes improved retrieval accuracy for specific definitions, but larger chunk sizes were better for summarizing concepts." That single sentence proves you are not just a tutorial follower, it proves you are an engineer who understands trade-offs. Finally, you need to measure success. In traditional software, we have unit tests. Pass or fail. In AI, the answers are subjective. How do you know if the answer is good? Look into a concept called RAG evaluation or tools like Ragus. These are frameworks that actually use another AI to grade the answers of your first AI. It sounds meta, but it is the industry standard for quality assurance. If you can show a hiring manager a chart saying, "My system's accuracy improved by 20% when I changed this setting," you are speaking their language. You have the theory, you have the stack, you have the project idea. The only thing left is to understand where this is all going and why making this move today is the safest career bet you can make. You now possess a blueprint that 90% of the tech industry is still trying to figure out. It is easy to look at the headlines about AI layoffs and feel paralyzed. It is easy to think that the era of the software engineer is ending. But look closely at what we just covered. We did not talk about magic. We did not talk about sentient robots taking over the world. We talked about databases, search queries, and data pipelines. We talked about engineering. The reality is that AI is not replacing software engineering, it is evolving it. The companies that are firing generic coders are the same ones desperately hiring AI architects. They are looking for the people who can build the librarian, who can map the data, and who can stop the hallucinations. You already have the logic to do this. If you can build an API, you can build a RAG pipeline. If you can query a SQL database, you can query a vector database. The barrier to entry is not intelligence, it is simply the willingness to learn a new vocabulary. So here is your mission. Do not let this just be another video you watched while eating lunch. Take the standard triad we discussed: Python, a vector database, and OpenAI, and build that simple journal app this weekend. Encounter the errors, struggle with the chunk sizes, because that struggle is exactly where your value is created. The engineers who treat AI as a black box will be replaced by it, but the engineers who open a box, understand the gears, and learn to control the system will become the architects of the next decade. We are going to be breaking down every single part of this new career stack on this channel. In the next video, we are going to move beyond simple retrieval and talk about agents. How to give your AI permission to actually do things, not just talk about them. It is the natural next step after RAG, and you do not want to miss it, so make sure you are subscribed. AI will not replace you, but someone using AI will. Be that someone.